All right, welcome. Today we are talking about inscribed angles, continuing with our look at circles. So if we recall, the term inscribed means that a shape is drawn inside a circle such that its vertex is on the circle itself. So an inscribed angle means that when I draw it, the vertex of the angle is a point on the circle. Well, the first thing that we need to know about inscribed angles is that the measure of an inscribed angle is half of its intercepted arc. So another way to think about it is the number of degrees running along the circle is twice as much as the number of degrees in the corner, or the number of degrees in the corner is half as much as the number of degrees running along the circle. So if we want to find angle P, notice angle P is here. P is a point on the circle. And if I trace out angle P, I notice it intercepts the arc from M to N. So that tells me that the measure of angle P is half as much as the arc from M to N, so 1/2 of 70, which is 35 degrees. If I need to find the length of the arc from P to O, so there's P to O. I notice that angle N intercepts the arc from P to O. The measure from P to O divided by 2 is equal to 56 degrees. Since we know that PO has to have a larger angle measure, we double the angle. And get 112. All right, the next thing to talk about. Because the inscribed angles always measure half of their intercepted arc, any two angles that intercept the same arc must therefore have the same measure. All right, so if I look at the picture, I notice both angles B and C intercept arc AD. So therefore, angle B must be congruent to angle C. So if I'm told to find angle T, I notice that angle T and angle U both intersect arc SV. So therefore angles T and U must be congruent. So measure angle T is equal to the measure of angle U. Therefore, 3x minus 5 must equal 2x plus 15. And now we can solve for x. Therefore, the angle T must have the measure of 3 times 20 minus 5 So measure angle T must be 55 degrees. All right, the next little theorem. So again, this goes back to what we were saying about how the inscribed angle relates to the arc. So I notice FH is my diameter. If F to H is the diameter, then we know that it goes directly to the middle of the circle. And I know that every semicircle measures 180 degrees. We notice the chords at F and H intersect at point G. Therefore, angle G must have half the measure of the semicircle. So anytime I have a triangle formed with a diameter, you always end up with a right angle. So if I'm looking for angle F, start with the same idea. So if there's 180 degrees on the arc from F to H, there's 90 degrees at angle G. And the diameter and the two chords together form a triangle. So I know the three angles of a triangle must equal 180. So measure angle F plus measure angle G plus measure angle H must equal to 180. And now from here, we solve it much like we did the earlier example. Combine our like terms, solve the equation. And since we are looking for the value of angle F, we can just substitute our x back into our formula and get the answer. So 4 times 7 is 28. Plus 2 is 30. So therefore, the measure of angle F is 30 degrees. All right, so for the next theorem, we're going to build off what we were just looking at. So we know that the inscribed angle always has half the value of its intercepted arc. If I take a polygon and inscribe it in a circle, what we'll hopefully notice is that the intercepted arcs of the opposite vertices fill the whole circle. And since the entire circle measures 360 degrees, the interior angles, or the opposite angles, I should say, are supplementary. So again, because the opposite angles have half the value of their intercepted arcs, the total of the arcs divided by 2 would give me the total measure of the two angles combined. So if I'm looking for measures A and B, I notice the intercepted arc for angle A combines with the intercepted arc for angle C to form a full circle. Therefore, A and C must be supplementary. And there we go. Similarly, if I want angle B, so the intercepted arc for angle B combines with the intercepted arc of angle D to make a full circle. So they are supplementary. And now we solve. And since we wanted the value of angle B, plug it back in. And that's all we have for today. I will see you guys next time.